Hey everybody, how's it going? So, we've got a very different type of game today. Shenzhen IO. However you say it, I'm not very good at pronouncing Chinese, so apologies. But yeah, so it's a circuit design and programming game, so let's give it a shot. I just loaded it up. And I'm not really sure what we're looking at, but looks like a computer. Looks like we got some email from somebody. Dear new employee, thanks for joining Shenzhen Longtang Electronics Company. Blah blah blah. Diligence, connections, and salubriousness. Whatever that means. An unhealthy mind creates an inefficient design. Follow correct eating, correct behavior, and correct thinking. Alright. Oh, and we got some replies. Fresh meat. Let's see. Welcome to southern China. I mean, Shenzhen is it's a real town, I think. I mean, I guess it's a city, probably. Alright, well, lots of people being nice, saying hi. So yeah. What security camera fake? Fake surveillance camera. Create a working design for this product. Oh, okay, interesting. So for people that don't want a real surveillance camera, you know, because you gotta upload all the data and stuff, you can have a fake one. Alright, so I need to work on a design for it. Let's see, you gotta read the manual. I mean, RTFM, right? Read the manual. Read the full manual? It means something like that. Alright, well, let's give it a shot. So we've got our CAD. Chengdu Gainan Information Technology. I mean, is there a... This looks like copyright. Oh, that makes copies? Sorry, we don't want to do that. Alright, so... What does this one do? Let's just name it. Alright, let's go ahead and open a design. So for our fake surveillance camera, active and network are simple output connections to the LEDs, and control the active and network outputs with fixed, repeating signals as indicated. We're jumping right in here, aren't we? What else is there? There's before we get started, there's a PDF for datasheets. Wait, does this actually open a PDF on my computer? It doesn't appear to do anything. Oh yes, it opened a PDF. Oh boy, what have I gotten myself into? Alright, let me get this on screen. Hold on. Let me just share one moment. This was an old window, hold on. There we go. Too big, let me fit it to screen. Oh no. There we go. Well, that's gonna be pretty hard to read, isn't it? We can zoom in a little. Oh no, they recommend printing it out and assembling a binder. What? Oh my goodness. I don't know if I'm ready for this game. So here's our language reference. I mean, I am familiar with assembly code. So I mean, these instructions are familiar sounding. I'm not sure what DGT does. Alright, so don't think that's important. These are just emails printed out. Oh, my visa application. It's kind of funny. Alright, so well, let's get back to the game for a minute. Has anyone ever actually tried streaming this game? It seems like maybe it's not a great idea. Alright, so let's go ahead and open our design. And, so this is what, the previous employee left us with. Let me turn it down a little bit. Alright, so what are we trying to do here? Oh, there's our security camera. Alright, so active and network are connected LEDs, and we want to use, control them with fixed repeating signals, as indicated in the verification tab. Oh, so active we want to, like, kind of go slow, and network wants, like, some of that. Okay. What do we got here? Whoops, don't do that. So we're probably gonna need another one of these, right? And when we actually just write code? Oh my. Alright, well let's see what, I'm curious what that currently does. So maybe we could just play it. Okay, well it looks like active already does what it wants. I don't know why I left a comment that it's so hard. So, oh, the SLP is probably sleep, right? Oh, I see, so it's moving, Alright, let's take a look at the manual. Alright, so hold on, let me put this behind me. So it's not blocking my face. Let's see. Nope. Okay, there we go. Alright, so there's two types of pins. Simple I/O and XBus. They are not interoperable. Can only be connected. So simple I/O are continuous values of signal from 0 to 100. 0 I guess being low and 100 being high, right? Alright, XBus. XBus are discrete packets from -99 to 999. They're marked with a yellow dot. Was there a yellow dot? I mean, the current microcontroller I have... Oh, maybe that's the yellow dot with the X0. Okay. Seems reasonable. Alright, so... those are used to transmit data between two microcontrollers. Simple I/O can be read or written to at any time, with no regard to the state of devices, but XBus is synchronized. It's only transferred when there's both a reader attempting to read and a writer attempting to write. Okay, it blocks otherwise. Make sure to get enough sleep. Yeah, CPUs are much faster. So to advance the... Both okay, yeah, so you want to sleep. That's what the sleep instruction's for. And here's the example of the square wave generator. So that seems pretty reasonable. And that's kind of how our example is set up, right? So I feel like that's enough to do this first example, because basically we want to do kind of the same thing, right? So start off with, oh, we need to connect the pin. Oh, thanks for the follow-up, Mavoa. Hopefully we can figure this game out. So it looks like we want to sleep for maybe like 2 or 4 maybe, and then we want to go high, and then maybe only like 2, and then we want to go low, and sleep 1 and go high again for 1, and then we'll go back low. Maybe something like that. Let's see what it does. Oh, hold on, that one needs to be 100. Oh, there we go. Alright, it looks like we've completed a test run. Oh, nice. So we met our production costs, our power usage. And I don't know if they're goals or whatever. Well, let's go back to our email. Alright, looks like blinking lights work. What else we got here? Why are we even here? Maybe we've got some community building type things. Well, whatever. Alright, what do we got now? So we need a signal amplifier. Oh no, it was broken. And then what else we got? My daughter's learning programming. Created a card game. Seems kind of cool. Oh, there's Solitaire. Can we download it? Solitaire is probably easier than, oh, there it is. Alright, let's try out his Solitaire. I don't know what those are. Oh, maybe there's like 3 suits. Is this a 0? I don't know what this one is either. Oh, instructions. Here we go. Oh, these are like the Mahjong suits, right? Alright, so you're trying to stack 1 to 9. They can be stacked, but they have to be alternating suits. Decreasing value. Oh, there's free cells at the top. 1 card of any type. When all 4 dragons are exposed, they can all be permanently moved to an open free cell. Alright. Now it looks like we've only got 3 dragons. The last one's up there. Oh, so I guess there's different suits of dragons. Alright. So we do have a free cell, right? So we can put stuff up there. But we should really try to get some 1, maybe. There we go. And so this is the same suit, so I can't do that. But I could put like the 3 here. And then there we go. We got rid of those dragons. What is that? I don't know what that is. Alright, really need to get to the bottom of this. Can't put it there. Another dragon. Probably just have to put a dragon up top. Oh wait, no, there we go. Alright, we could put a 3 up here, right? Don't see why we wouldn't want to do that. But it doesn't really get us anything. In fact, I'd probably want to do this. And then get rid of the dragons. Nice. Alright, so that's a full stack there. We don't have any more free spaces though. Oh, there we go. That was good. That got us most of what we needed. Oh, there we go. Nice. Alright, Solitaire, yeah. That's kind of a neat variation on Solitaire. Alright, but we don't need to play too much of that. Let's go back to work. So we gotta work on our next project. So we're trying to build a control signal amplifier. I've only got one thing here. So control in is a simple input. So we want to connect it to the simple input, yeah. And then there's a simple output. And the signal should be multiplied by 2 and copied to control out. So that seems pretty straightforward, right? Because we probably just do like, well, we probably need to multiply something, but we don't know how to do that. Oh, we can probably use add, right? Well, let's look at our our circuit diagram. I mean, our instruction book. So this is an example of a touch-activated light controller. Oh yeah, I've got a lamp like this, where when you hit it, it changes intensity and then goes off. Oh, in this case, it looks like we need 2 microcontrollers, maybe. Oh, they're communicating over X-bus. So the first one reads in the capacitive switch. I mean, simple pin 0. Oh, and that sends a 0 or 1 over to this guy. Oh, but we don't have to do that here. Because we're just gonna use the oops, I didn't mean to do that. We're just gonna do the shift left instruction. So let's go ahead and bring up the example here. Let's see. How do registers work in this? Okay, so it looks like we can, like, you take an input and shift it left. That's a test. I kind of want to see the instruction reference. Can I go to shift left? Is there not a way to jump to it? Oh, that's sleep until. thought it was shift left. Okay, so that's sleep until there's data on the pin. We don't really want to do that. In this case... yeah, arithmetic. Okay, mul. Multiply the value of the first operand by the value of the register and store the result in the register. Is there examples? That's about the parts. So I assume we can do... let me see if I can find an example of mul. I guess not. Oh, okay, it's just register an integer. So I want to say we can probably just do mul p02. No, that's not right. Oh, I typed it in, by the way. But it said there's too many operands. I mean, is somebody supposed to have like a slash, maybe? That would be kind of weird, wouldn't it? Too many operands. I guess we'll go check out the sample again. I wouldn't expect that I would need... like, I want to do multiply, right? Unless the number is supposed to come first. No? See, we don't need to do any conditionals. Oh, ACC is the general purpose register used for internal computation. Okay, maybe that's what we need to use. So we probably want to move P0 to ACC. Then we want to mul ACC by 2. Maybe it's just a mul 2 or something. Hey, thanks for popping in, man Alex. We're trying to figure out this programming game. Alright, so I think that's what we want here. So basically we'll move P0, the input, into the general purpose register, multiplied by 2, and then see if that works. Oh, that's not sleeping. So we probably want to sleep 1 afterwards. That's not doing anything. So, okay, yeah, the arithmetic instructions work on that. Did I get the move backwards or something, maybe? I think I got the move backwards. I'm thinking about it more like x86 or PowerPC. There we go. Well, that was easy enough. Pretty straightforward. Yeah, you just gotta read the manual. RTFM. Alright, well, nailed it. Alright, let's see. Oh, they're gonna let out all the parts available, but they're not all gonna be useful right away. Alright, what are we gonna build next? Diagnostic pulse generator. We need a pulse generator to test some other stuff. So we're gonna need to make use of conditional execution. Oh no, we've got so many parts now. Oh, thankfully it says, which ones are not recommended. Alright, so we've got a button, which is a simple input. And we got the pulse, which is a simple output. When the button is pushed, generate pulses as indicated until the button is released. Okay, so as soon as the button's up, then we jump back and forth. But then when they let go of the button, then we stop. So we're gonna need to check out conditionals. So conditional execution, prefixing an instruction with a plus or a minus, cause that to be enabled or disabled by test instructions. Okay. And all conditionals start in disabled state. What kind of pieces are we going to use, I wonder? Let's see, the notes. It's just like a comment or something. We've got a bridge. We've got a 4,000 and a 6,000. So they can talk to each other across the XO buses. Let's take a look at the light sample again, because that'll probably be helpful, right? Where was that at? Here we go, the touch-activated light. So this is like when you push the button, it tests if the current value is 0. Oh, and it also tests the button. I see, so because you only want to do something if the button is pressed. Interesting. So we're almost certainly going to want just a simple input there, but then we want to test the button. Okay, I think I know roughly what we want to do. Because what we could try is like, something like, fifth the button. Hold on, let me think about this. We might only need one piece. Because we want something like test if P0 is 1 or something. Hold on, let me look up the test instruction again. Oh, it's gonna be 100. So yeah, it's gonna be something like, test if that's 100, and then if it is 100, if it is, then we want to do, move, 100 into P0, P1. Let's go ahead and connect that. Can we put this back? It's gonna be like sleep 1, move 0 into P1, sleep 1. I don't know if that does what we want, but let's try it out. Oh, part not sleeping. Oh, so and then probably another sleep 1 at the end. So that's not quite what we want, but kind of close actually. What we might need is a minus here. Oh, look at that, beautiful. Beautiful. Does anyone have any questions on why this works? But yeah, basically, to explain it real quick, so if the button's down, then we execute all the instructions with plus, otherwise we execute the minus instruction. So if it's not down, we just do sleep 1 and loop around. Otherwise, we do our down press to get it up, the move 100 to get it up, and then we sleep 1, move it back down to 0, sleep 1 again, then it'll loop around. So yeah, pretty straightforward actually. So we didn't need too many other complicated things. Take an orbital selfie. Trip started just 89,999 Rs. It's a lot of Rs. I don't think so. I don't think... Man, it's Moscow. Let's not say too much about Russia right now. Alright, so we've got a animated esports sign. Oh man, it's a deal with a major esports personality. The Solid Steel Gamer. It's a pretty cool name. Our team's contacted us to make light-up signs. And then what is this? Bring out the Baron, we need a drinking game scorekeeper. Baron von Schnaps is in the house. Yeah, wait, what's the game? What counts as a point? How it's a foul? Alright, let's try the light up sign first. Alright, so click 0 and 1 are inputs. Connect it to display segments. Oh no, those are outputs. Wait, I thought this was the light up sign. Okay, I guess the esports thing is also drinking animation. So 0, 1, 2 are simple outputs connected to display segments. So control the display segments with fixed repeating signals. So is there no output? Oh, okay, then now I understand. Alright, so click 1 and 0 are opposites, basically. Does this have 2 outputs? No, it's only got 1 real output. So, I mean, something simple like that. Oops. I didn't want to put that wire down, but... Oh, I definitely don't want to do that. So just to verify, so that's our click 0. But I wonder if we can somehow drive click 1. I don't think we really can though, because we don't have any parts that have 2 outputs. But whatever, we can just do something pretty simple. So there's click 0 and 1, piece of cake. So then I guess for these, man, I feel kind of silly just putting in... But none of these parts are recommended, so I guess I won't worry about it. I mean, we'll just dump in a bunch of these, right? Oh, can we actually have P... Maybe we can have P1 do something, right? That might be better. How do we delete stuff? I guess we just rip it up. How do we... Okay, there we go, right click. So I was thinking, maybe I can have, oops, P0. P0 is what I want. Oh, that's backwards. Wait, why is it backwards? I thought it was... Well, whatever. We'll just change. Actually, let's leave it hooked up like that. Nope, not like that. But we'll just change. There we go. much cheaper solution. I've cut the cost in half. Pretty amazing if you ask me. That's why they pay me the big bucks. Alright, we still don't have a way to drive 3 things at once, though. Oh, that's crazy looking. That's just buses. I mean, I'm just curious what other parts we got. Yeah, I don't know what any of those do. Let's not worry about that. Alright, so we can probably get away with just 2. It does seem like a bit of a waste. And it does seem kind of weird to, like... I wonder if, like, one of these should drive the other one somehow. Alright, so let's copy some of these code. I don't feel like typing it again. Alright, so just to check, we definitely don't want it that fast. Maybe it's like 5 and 4 or something. Pretty close, but 6 and 4. So then I was thinking, oh, actually, yeah, probably best to just use this one like this, because if we hook it up to the other one, the outputs don't quite line up. Alright, so, it's gonna be at 0, and then after 6, P0, P1, P0, it'll go to 100 for 1, then back to 0 for 2, back to 100 for 1, and back to 0. Actually, it's probably just 1, right? Oh, I don't really need that. Maybe just 2. Alright, and then P1 is basically gonna be a bit of like the inverse here. Oh no, does it only support a certain amount of code? Because that's gonna be making it tricky. You're telling me I can't put any more code in here. Alright, hold on, let's first just check. So that is correct. But we might not be able to do it with, oh, maybe I can stick it in this guy then. Although I would have to put a lot more sleeps in, so that's not great. Man, I really can't fit in more than one line of code. Alright, fine. We'll just do it this way. Gotta switch to P1 though. I wonder if I can get away with... it doesn't have enough outputs to really... Oh, yeah, I see. No, I still don't have 3 outputs though. Because we could connect the X1 or 0 to this guy. Right? And then we would have 2 outputs. Which would be a little cheaper maybe. We've got more code as well, right? Yeah, you can write a lot more code. So that would be like, one yuan cheaper. But, not enough to, not enough to actually worry about doing this. Alright, so, we're gonna sleep 1. Yeah, let's actually just sleep 7, I guess. And then we'll go to 100. And then sleep 2 and go back to 0. Actually, maybe that's all we need. Yeah, oh no, that's a little off. Yeah, the 7... maybe, wait, hold on. Okay, we'll just have to do it this way, I guess, to make it line up. That should make it line up. It's a pretty funny sign. Yeah, we probably could have had a cheaper production cost by using the triple guy. But it only would have saved us like one, maybe. Oh, we were a little over the average in lines of code, too. Oh well, that's fine. Alright, let's try the drinking game, I guess. Oh, we've got this cool LED thing. So point and foul are simple inputs. Display is a cross bus. And the counter should keep track of a count. Starting at 0. And ensure the display is always showing the current value. So point is increment by 1. Foul is decrement by 2, but not below 0. Well, this certainly seems a little trickier. So, what does a bridge do? Does it just let you... Oh, it just makes your design a little easier. Alright, so how do we want to do this? I mean, the simplest would be something like, this, right? And connect these all. But maybe it doesn't make sense to do that, actually. Because we might actually just be able to do this. Oh, I guess that's what the bridge is for. Oh, it needs to go in the other... Alright, so maybe we can get something like this to work. Oh wait, don't I... Wait, why don't I just have it all go into one thing? Yeah, so hold on. Probably don't need any of this nonsense. Yeah, we just have, oh, we're still gonna need a little bit of a bridge, just to get, oh, maybe not actually. Yeah, there we go. Alright, so maybe we can get it to work with just this. So something like testing, so P1, if it's equal to 100, I guess. Like, let's just get it working for this first. Oh, we've got a data register as well now. Let's check out what that means. Alright, so that's a second register. And it can be used in most contexts. Well, that seems straightforward enough. Alright, so if P1's 100, then let's increment maybe our ACC value maybe. Hold on, is there an increment instruction or something? Oh wait, maybe we can use some jumps. Okay, so add. Let's try that. And then maybe, we'll move, ACC index 3 and sleep 1. So I expect this will maybe be enough to do something. But our decrement doesn't work. But that's fine, that's fine. We didn't think it would work. Alright, so now we want to test if P0 is 100. And if that's true, was there a decrement instruction? Sub. So sub 2. So this won't work because it'll be negative though. Now we can do if, let's see, there's more tests, aren't there? So there's, equal, but there should be, like, less than or greater than. So if the A value is less than the B value, but what we might do, yeah, I mean, that'll be the simplest, I think. So we can do like, test less than, so if, ACC is less than 0, then, we want to move 0 into P in ACC. Alright, I think we did it. Piece of cake. Alright. Oh man, somehow people got cheaper than that. But I only used one piece. Oh, I used a big piece, didn't I? Oops, oh no. Hold on, I wanna... Did I probably could've used the small piece, right? Yeah, that's all we needed. Let's use the small piece instead. Might as well save $2, right? I just wasn't sure how much code we were gonna need. There we go. Now we're right in mark. Somehow people use less power. And let's not worry about power usage. Alright, what do we got here? How do you say the ZH? Do you ignore that? No, you can't. CH is its own sound in Chinese. Okay, so it's Shenzhen. Shenzhen. But yeah, yuan's the currency. Oh, is that not how you say it? It's one syllable, yuan. 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 I apologize to anyone that speaks Chinese. Oh, it's the same symbol as the N. Interesting. Alright, what do we got here? Harmonic Maximization Engine. Alright, well, let's take a look. So we've got audio in and audio out. And we've got a maximize signal. So audio in should be copied to audio out, applying the harmonic maximization algorithm. Oh my, what is that? Look in the supplemental data section of the manual to find an advertisement. What is this? So, supplemental data. These are still parts, right? Oh, this... not the same thing. Looking for the harmonic maximization. Oh no, that's really in Chinese. Alright, here we go. Harmonic maximization. So audio out is going to be equal to audio in minus 50 times 4 plus 50. That's easy enough. Let's just go ahead and copy that. Oh, I can't copy that. Alright. Minus 50 times 4 plus 50. Alright, that should be good enough. Alright, so to do this, we're gonna need definitely one of these, maybe. We're definitely gonna need two pieces because we need three inputs, right? Or output, input plus output. So we might be able to get away with two. Maybe, something like this. Alright, so... and we could probably use X0 as well. Maybe. Well, let's try figuring it out first. Alright, so... I feel like we just want to do something simple-ish, like, if P1's 100, that means the button's on. Oh, maybe like, we're going to move P0 to ACC, and then if the button's on, then we want to do a bunch of math, right? So we'll do all the math, and then we're going to move ACC to X1, and then, I guess we just move. Oh, we probably need to wait for X1, right? I need to look up that instruction again. Hold on, let's go find it. Let's see. There was the sample, right? Here we go. So we're going to want to do something very similar to this. Alright, so we sleep for that and then move it. Alright, that should be really simple. So basically we just grab X0 and move it to B1. Alright, so if the button's down, then we need to subtract 50. Then we need to multiply by 4, and then we need to add 50. And that should be all. Oh my, we gotta put a sleep in there. Otherwise we really flip out. Alright, well that was really simple. It's a shame we couldn't do it with just one part though. But hey, good enough, right? Wow, how did somebody get it with just 4? And what could they have possibly used? This thing? Or this thing? Probably not this one. Yeah, what even this takes? I don't know, it's got a bunch of cross inputs. Yeah, I don't know. Too complicated for me. Wait until they introduce that to us. Alright, well that was pretty cool. Self-driving car stuck in a loop. You may be entitled to a settlement. Yeah, you gotta watch out for those Teslas. They may drive you around in circles. Alright, maybe we'll see if we can do one more, and then we'll call it a day. Yeah, we've got quite the interesting part here. And a sensor, what are we even doing? A passive infrared sensor. We've got time. On time and off time. So time is the current time. Sensor is the infrared sensor. Alarm is the alarm. So when the time equals the time, the device should be armed. And when it's the current time is... Oh, this must be the actual time. And this is the on and off time. When the device is armed and the sensor reads at a value above 20, at or above 20, then the alarm should sound. On and off times are set by the operator using dials that can be read as XBus inputs. Okay, that seems straightforward enough. Oh hey, thanks for the follow, Snower Fantasy X. Do you like programming? This circuit design plus assembly is a little more challenging than what I normally do. Alright, let's see. What's recommended here? Just our same parts. Interesting. Well, we're probably gonna want... I wonder if we can get away with just this. Probably not, because we've got two time inputs. Oh, I might need to look up what this component does, really. I mean, I would expect, Alright, let's put these guys up here. Not like that. Wait, why is that a pin type mismatch? Oh, I thought it was a cross. Oh, it's a simple input. Okay. That makes it more complicated because we're gonna need, Alright, yeah, we don't want that. Alright, so, instead what we want is this guy. And we're gonna say, whoops. Alright, yeah, let's do it like this. Oh wait, no. Yeah, no, that should... Oh no, we're gonna need another cross. Circuit design's a lot harder than I thought. Alright, yeah, let's see if we can make do with this, maybe. So, oh, it's simple, yeah, it's input. Alright, so our two time things, let's have them come on here. Alright. Then, we're gonna have the sensor come in. And this is the output for the alarm. And then we just need a bridge for that guy. Alright, that should be enough pieces to do what we want. So now we need to look at the timer. So basically, if we're armed, this guy's gonna take care of if we're armed. This guy's gonna check all the time. Alright, so if x0 is equal to p0, then we're armed. No, that's the off timer. So let's move a 0 in ACC maybe. If x1 is equal to p0, then we'll move a 1 into ACC. And then we'll move ACC into x3 and sleep. So basically, we'll just check if we're armed or not. And pass that along. So then if we're armed, which would be if X0 is 1, then we want to check the sensor. So, if test greater than, was that what it was? If P0 is greater than 20, or maybe 19. Probably gotta look at our manual for that, but I think it's not inclusive. If that's true, then so maybe something like that. Oh, we need to sleep for the cross input. Alright, well, that's a lot of code and circuits. Do you think it works? I think it might work. Oh yeah, look at that. Isn't that beautiful? It's almost like I'm a programmer. Man, somebody got cheaper. How did they get even cheaper? I mean, wires are free, right? I assume they are. Alright, well, looks like it was well received. Alright, well, I think I'm done for now. This is kind of an interesting idea for a game. It's, I wonder if I didn't have some background in assembly, though, if it would be quite a bit more challenging. Not really sure. But yeah, that was still pretty fun. I don't know if I probably won't stream it again. A little too complicated, I think, but got the manual. I didn't think I would have to load up a manual. But it does feel a little bit like real work, which maybe not so fun. Alright, well that's enough for today. Thanks for joining me, everybody. Hope you enjoyed this look at Shenzhen. And yeah, next week, I think there's some more Game Pass games I want to try coming out. I also kind of want to play Rumbleverse, and I want to mess around with Godot, the programming thing. So, some of that coming next week. We'll see. We'll see how it goes. But yeah, I will see you later. Bye-bye!